All right, my name is Victor Rodriguez-Ortiz, and today I'm going to be studying the diffusion of milk in cereal over different temperatures. So essentially what I'm going to be looking at is how long does it take for cereal to become soggy or saturated, as I'm going to be calling it. And we've all been there. We've taken a bite of our cereal and it just tastes like mush, and it's not a great feeling. And so that's why I want to study it and see if we can glean any information from it. And so, as we know, the diffusion coefficient is dependent on temperature, and it changes. So it changes with temperature, and so our answer depends on temperature. And another thing our answer depends on is the type of cereal here, which we'll see in just a second. So talk about my experimental methods. On the right, you can see the cereal box that I used. I used very generic cornflakes, and what I was mentioning before about the type of cereal is important. It's because a lot of cornflakes nowadays can have sugary coatings, and so that can actually affect the time it takes for the cereal to become soggy. You can also see this cup on the bottom, which is what I used, or how I ran my experiments. I essentially had some milk at different temperatures, and I just estimated how long it would take for the cereal to become soggy to the point where it's inedible or where it just fell apart as I picked it up. So like I mentioned, sugary coatings can slow down the diffusion, and we entered three temperatures, which were cold, room temperature, and hot. So here's essentially a table of all my results. And so you can see the cold temperatures, which were about 37 degrees Fahrenheit, which is from my refrigerator. It came out to be about 15 minutes, close to 16 minutes, for cereal to become completely saturated. For the room temperature experiments, about 11 minutes were measured for the saturation time, and for the hot temperature experiments, about 4 minutes it took for the cereal to become saturated. So I also did a total of 18 trials. These are the results from the previous, but in a bar graph form, so it can be easier to compare. As expected, as the temperature increases, the time it takes for the cereal to become soggy decreases, so milk diffuses quickly, and we'll see that. So I had my experimental results, but I also want to see if I can calculate the diffusion coefficient, or at least estimate the diffusion coefficient. So essentially, at first I wanted to use the penetration depth equation, but that equation is only good for your penetration depth being less than your thickness. And in this situation, as you'll see, I wanted to use my penetration depth equal to my the full thickness of my medium, which is the cornflake. And so this is the equation we'll be using, of course, with some simplifications. On the left-hand side, the row terms are actually the local densities. And so the rho sub A is the density of milk in the cereal, or the mass of milk in the volume of the cereal at the beginning. And of course, we're taking it to be 0. So those come out to be 0. And for the concentration at the surface of the flake, I'm taking it to be unity, or 1. And so this equation simplifies now to this equation here. And so there's a couple of terms that we'll need before we can get the diffusivity. The first one being this local density, which essentially is the mass of milk per volume of flake. And I took that to be at the most saturated point, right? Because we're interested in studying the saturated cereal flake. And so we'll see how I measured that. We also need the flake thickness, which we can measure, and we'll see that. And finally, we need the time, which will come from the results we had in the beginning slides. So with these three terms, we got able to calculate the diffusivity. Before we can get to diffusivity, of course, we need to get this local density. And so the way I did that, if you remember, we need the mass of milk in a saturated cornflake. And so what I took about 22 trials. Here I specified the number of flakes because initially I didn't know if the number of flakes would affect the accuracy of the scale, but fortunately I was able to use a lab grade scale, so I just eventually ended up weighing one flake at a time. And so I weighed the dry weight, I let it soak in cereal for 2 minutes. It was warm cereal because I wanted to expedite the experiment. So I waited for it to become fully saturated so it could absorb as much milk as it could. And then I took the difference between the wet weight and the dry weight, and I come up to be an average difference of 0.263 grams. So essentially, on average, one cornflake can absorb 0.263 grams of milk. But so we have the mass of milk, the average mass of milk. So now we need the average volume of a cornflake, because remember the density term is mass over volume. And so I estimated the cornflakes to be an ellipse. And so here's the equation for the area of an ellipse, where A is half the length and B is half the width. I took length measurements. I basically just measured the dimensions of cornflakes for 22 trials to get an average. I took the area at each one of these. As you see, the area of ellipse formula is there. And then I multiplied times the thickness. The thickness was, for almost all the samples, it was essentially 0.1 centimeters. So I multiplied that and we get our volume. So now we have down here the average cornflake volume, which comes to be about 0.301 cubic centimeters. So coming back to this equation, we have the mass of milk and the volume of flake, which we measured, and this comes out to be, on average, 0.872 grams per centimeter cube. So essentially, for a saturated cornflake, there's about 0.872 grams of milk for each centimeter cubed. The flake thickness I mentioned previously was about 0.1 centimeters. And the time, well, we're going to get those, well, we've already gotten those from our different experiments. So at the cold temperature, there's an average time taken to become saturated. At room temperature, there's an average time for the cornflake to become saturated, and at the hot temperature as well. So once we get all these, we can calculate the diffusivity of milk and cereal at the varying temperatures. And here are those values. So at the cold temperature, we have about 3.2 or 3.3 times 10 to the minus 3 centimeters squared per second. At the room temperature is about 4.6 times 10 to the minus 3. And for the hot cereal in cornflakes, it's about 1.31 times 10 to the minus 2. So it's about an order of magnitude greater. So I've also written it here for comparison in meters squares per second. And looking at these values, they're within the realm of possibility. They make sense for a diffusion coefficient of liquid. They're about in between liquid and gas. But since the diffusion coefficient for liquids are typically 10 to the minus 9 within that range, you're satisfied with these results. As we see, we expect the diffusion coefficient to increase with temperature, right? Because the molecules can move faster and diffuse faster through the medium. So these results make sense, at least physically. So now I want to talk about the limitations of my experimentation. So of course this is a home experiment, so there's limitations in the instruments that I could use. I was able to use a lab grade scale, so that's good. But as far as measuring the temperature, well, yeah, there might be some inaccuracies there. Another thing, for the application of this, we could use these diffusivity values to maybe back calculate the time if we're interested in that, and we get some practical application that way. But as I mentioned previously at the beginning, a lot of cereals nowadays have sugary coatings. They have different shapes that might affect the diffusivity. So that's one limitation of this experiment. And also, as I showed, I use these plastic cups for my trials, and so those can leak heat. And so if we were to repeat some type of experiment like this, then I would use some type of insulated container to try to keep the temperature as uniform as possible over the measured time range. So here are a couple of the references that I used. All right, thank you and have a good day.